Is my screen visible to all? Akshit, are you there? Shai Akshit?
Yes, yes, sir.
Okay. So you're from 11th grade, right?
Yes, sir.
Mm-hmm. Okay. So you joined like today's class. Anyhow, today only we are going to start wave optics. New chapter today.
Uh, okay, sir.
Yeah. So wave optics and dual nature and all those optics things, they all are similar. In dual nature, we saw that light is like dual, it has dual nature. It's wave as well as particle. Wave nature and particle nature. Okay, wave nature in the sense they can form, they can follow the wave rules, and particle nature means can follow particle rules. Particle rules means like they form as a particle, smallest particle. So in dual nature, especially we studied like about particle nature. Like we saw those Rutherford theory and all the theories we saw. In this one, we will see about wave theory. So before going there, let's see some chota topics. Anytime if you're not able to hear me, you tell me, because I don't know, like my internet might be fluctuating. Right now you can hear me, right? Properly? Can you hear me properly, or it's not proper?
So we can hear you.
Okay. So first thing we have to know, that is wavefront. Like see, wavefront there are types of wavefronts. One is spherical, cylindrical, plane. Name itself you can understand spherical shape, means cylindrical shape, and a plane form. Okay, but what are these? If have you heard of this wavefront anytime? Have you heard this term, wavefront?
No, sir.
Anyone?
Yes, sir.
Yeah?
No, sir.
No? Okay. So like, as you said, yes, you can just give me small little idea, whatever you remember.
Sir, I think wavefront is where all the particles vibrate in the same medium.
Perfect. So wavefront means wherever it starts, originate, or circulate, or move in form of wave. Okay, so suppose, as I said before, spherical. So spherical, if I consider here, they move in spherical shape. This is your circular form. So it goes in radially. Yeah, perfect word is radial. The spherical wavefront follows in radial path. In that, we can consider half portion as, see, this is moving outward. Some, if I consider inward movement, there is also a spherical part only, moving inward. In this one, they are moving outward. Whatever it is, doesn't matter. That we will see in later, little bit detail. But right now, we are just seeing what is wavefront. So it is concentrated on center. It's moving radially outward in this spherical part. Now, same way, if you consider cylindrical part, same way it's moving outward or inward also depends, like depends upon particles. So right now we'll not see particle thing. We'll just see wavefront, how it moves, wave. Only it is all about wave. Okay. So let's make it very, very simple. Wave front. Just we need some little understanding. So it is a point like where all particles of medium vibrate. As she said, vibrate. Let's rephrase the statement. No, this is okay. Let's erase this one. Yeah, let's add something here. Locus in mathematic term, locus of all particles of a medium vibrating in same phase of given instant. Given instant means at particular time. Now this thing depends upon source also. As I said before here, I drew spherical, I drew cylindrical, I drew plane. So this depends upon shape of the source. So let's write a point or else you will forget. So depends on shape of source. One, spherical. Spherical wavefront. So let me draw this again. Okay. So like this, we can go for all the direction. All the direction. Now same way, if I draw half circle here, this is converging times. We can say here spherical wavefront. This is converging wavefront. Same way, if we say here, this is your diverging wavefront. So in short, what we are doing, we are concentrating on one particular point. Here it is O, and here also O. So we have one point source from where all the, what we gave name, locus. What we said, locus. Locus of all this points are subjected here. See, that also we have drawn two different ways. One is converging, means one, it is moving towards one point, and another one, it is originating one from one point. Two different ways. Diverging spherical wavefront. Let's go for next. Guys, are you able to understand? Aditi?
Yes, sir. Yes, sir.
Yes, sir.
Okay, Madhusudan?
Yes, sir.
Okay. If you face any difficulty, you can ask me there itself. Because instead of writing in chat box, I can't change it here. Yeah, maybe like this we can go. Then next is your cylindrical type. Hmm. You can draw here also same. Same as down. So these are O, center O dash, O dash. So this is what cylindrical type. In cylindrical type, what is the difference between spherical cylinder? We have one straight line here, straight path joining one end to one end. So there is a linear path, like we can say linear divider is dividing linearly. So here also, in both cases, we are seeing that all points are equidistant. Observe this, all points are equidistant. I've drawn this sideway, but actually it is circle only. So here, all points are equidistant. Now another difference, we can say this is in the surface, on the surface of this. Cylindrical is on the top of the cylinder, means it lies on the source is lying on the surface of the cylinder. Surface of cylinder. Okay, this is inside the sphere. So sphere is the source. Whole sphere is a source. So let me change color so that you will remember here. So this is the source is surface of the cylinder. Is it easy to understand? Then next we'll see like Huygens theory, then all other theories, wave theory and all. Like it's simple, very very simple. Just listen like story, you will understand everything. You'll remember everything. Plane wavefront. So if I draw one, some wavefront here. So these all are like here, this side. So can you guess this wavefront? What it is, a whole source or just point source? See here it was whole source here.
There's
Here
a
the
point
surface
source.
of this. Yeah, you said something.
I think it's a point source.
It's just yes, point source means all small parts will be the source of it. Correct. Because the reason is that whole like plane is considered right now plane wavefront. Here cylindrical wavefront. So cylindrical part is like top and bottom here. This is just sphere's wave source, wavefront. I mean, so whole sphere will be the source. So if I write here a small part of what? Let's compare with sphere or cylindrical or cylinder or cylindrical wavefront, like due to a distance source. This will be appear plane. So here we will see like all the point as a source. So all small parts of sphere or cylindrical. So if we see from like, it will be like small thing only. It will be assumed as a small thing. We can say like that. So if you can assume this all are, assume if you can observe this all are parallel rays. Now clear with wavefront? Everyone? Yeah, done. There's nothing much here. We'll go up with Huygens theory. Have you done all drawing all these three? Everyone?
So
No, yeah, no, it write so much here. Just
can you send these notes in the group?
yeah. I haven't sent the previous one also, I guess.
Yeah, so you didn't.
Actually, I was not able to convert this into PDF. Okay. Shall we go to Huygens theory? Fine. I guess done, everyone, right? Okay. I'll just give you overall idea of Huygens theory. So no need to write derivation or something like that. It's simple thing. You just listen like story. Can you hear me right properly?
Yes, sir.
Okay, super. So simple words, if I say like what he said, like let me give you like small idea. Like he said that everything, all the waves makes it started from some source, as we saw here. All the waves which it has some source, like each point from this one has some source. So they started from this source. So like this, where is this one? Yeah. As you can see here, it all started from the source somewhere here. So each point or each this small like waves, they are called wavelets. He said it's just a source. This is a source, and they all like appears like that. They starts from here. Okay, so each point it starts from source. Like what is it? Let's talk about cylinder only, and they are called wavelets. Small waves. So now if we like expand this like disturbance and all that, we can form a one direction of it. If we talk about one single wave, it will show one direction. If we spread in some single waves, it will show some direction here. So like it has like, see, one goes away. If I draw it some, let's take that previous chapter ray optics diagram. Even like 10th standard also you're done. Those who are new to this topic, we can also understand if I draw some. Do you remember that? What do you call? In 10th standard, you study something, no? Yeah, regular reflection. If I take your regular reflection, if I draw one more regular reflection, if I draw one extended ray here. So this is your regular reflection, right? Do you remember? 11th standard guys? 12th standard we know because they already studied in like ray optics. But 11th standard guys, do you remember this? Regular reflection? You studied in like 10th, right? Say yes or no?
We haven't started the lesson yet.
No, you're studying 10th standard. I taught you, Aditi.
Okay,
Remember?
in 10th. No, sir, we didn't have that. We had,
Yes. Light reflection and refraction.
sir, I have my 10th class with you. I'm just checking it just a second.
Okay, fine.
Sir, no, sir, we had refraction.
Yes, that we had. That's what it is about. Okay, fine. If you don't remember, also no problem. If you remember, then also good. So yeah, there we saw incident ray and reflected ray are equal. A ray, what is this? Same goes here. This is a regular reflection. Okay, we are not going to that part, but what I'm trying to say here, if I extend this ray, see this point, observe this point, and A and B, C and D, D, E and F. Now, when this point A is reaching C, B is reaching D. So this is the primary, AC is primary rays for BE. AC is the primary ray for BE, which means because it is ahead, AC is ahead of BE. Because when A is reaching C point, a particle at A is reaching at point C, particle at B, it just reached D. Then when particle of C reaching F, that time particle of array, that time particle of this particle is reaching E, that time particle already ahead. So this particle at C, it is reaching F. So in short, in one cycle, A, C, and E, F. So particle at A reach C and F, but particle at B, it is reaching only at E. So it becomes secondary. So this is your primary wave, that is your secondary, means it is ahead. Now, another example, if I give you, have you been to lake somewhere? Have you been to lake? So have you been or not?
Yes, sir.
So if you have observed when you're throwing a stone there,
Ripples are formed.
exactly. Now, if you observe the ripples very clearly, it is when you're throwing a stone somewhere at the center. So it started moving one wave. So another wave is starting. So it will push this wave to move here because another wave is coming here. Then next wave is coming. So this will push this previous one. Then previous one will push the previous one. Then another wave will come.
It covers a larger part and then it stops.
Yeah. That is outer one, means once its energy get over, once its energy get eliminated or utilized, it will be stopped. It depends upon the force of our object thrown or the weight of the object. Depends upon both. That is not our topic right now. We are just considering like how this wave front and primary, secondary, what is the meaning of this primary and secondary and tertiary or whatever. After that, I don't know counting, 4 shari, 5 shari. I don't know those things. Whatever sharis are there. But here, what I'm trying to say here, whenever we are throwing some object on the lake, it will start forming a ripple. So it formed one wave. So it is one. So again, another one is already, but it will not stop. I'm talking, it will be non-stop going till energy get eliminated. Suppose it's going till here. So one wave already started, immediately another wave is starting there. So this one wave is at here, another wave will start. So this will move here, it will push them here. One will be here, then it will be second, then another will start. So one will be here. This is second, this is third. Another one will be here, second will be here, and third will be here, and fourth will be here. Same way. One will be here, second, third, fourth, fifth. Again, 1, 2, 3, 4, 5, 6, like that. So keeps on going till its energy get eliminated or utilized. Suppose this is the end, so one will stop here. Instead of this wave like this, it will become flat. Once it becomes flat, means energy is utilized. So in short, what is my point here? So when one was starting, there is a secondary wave pushing the primary wave to move ahead. So same goes here. If you consider like this, the wave which we are looking at this, it is actually, this is a wave like this forming. But if you look on the side view, this is a top view. If you look side view, it is like this. So that is why we got idea of drawing a waveform and all that. Okay, so understood what I'm trying to say here? Like all this wave theory, this is the wave theory. It has some like what do you call primary, tertiary waves, secondary, I mean to say. Clear? Let us write a point. Otherwise, right now you'll remember, but then you will forget. So let's make some points
Could
here.
you explain that again?
Yeah, sure. I'll write in some words so that you'll understand better. Let me make some words. Okay. So what I said before, each wave. Let's start with the same point. Okay, it is about previous point, right? Each wavelets. Each point source of light is a center of disturbance. So our stone was center of disturbance. I gave you example with stone. Actually, we are talking about light only, but I gave you example with stone. Similar configuration. From which waves spread in all direction. So here wave is spreading in all the direction. Even stone was spreading in all the direction. Once we threw the stone, that wave started forming in all the direction, radially outward. It's not just one direction. Next, about wavelets. Each, from here only I'm writing, each point on primary wavelets acts as a new source of disturbance. So it is disturbing other one. So one is disturbing other one. So that's why it keep moving there. Is there maths class waiting? Oh, yeah. Eight. Wait 1 second, please. Okay. Let's finish this. What I was saying, yeah. Wavelets acts as a new source of disturbance and produce secondary wavelet. Travel in a space. I am including here speed of light also, because light, we are talking about light. We are not talking about stone and water. Stone and water was just an example to understand. Speed of light. Let's write remaining points afterwards, because your class will start, I think so, in maybe, yeah.